Hello scholars. This week we will be playing and working with the concept of velocity or rate of speed as a form of slope, and the concept of acceleration or change in velocity as a form of change in slope. So for today's project, you will need a tape measure to mark off a 20-foot distance, some form of a stopwatch, and either chalk or an item of some sort to mark off the end of your distance. You're going to measure out and then walk or run that distance and time yourself. When we're on campus, we'll be working in teams of 3, but if you're doing this remotely by yourself, you'll need to time yourself. So what you're going to do is you're going to get your timer, you're going to set it, and then you'll start at your starting line, hit your timer and go, hit it again when you reach the finish line. You're going to do this 3 times. Try to do it at 3 different velocities or 3 different rates of speed. Working on campus, we'll be working in teams of 3, and each person will do it. You can have a partner time you. Yell go when they start their timer. You go, you take off, you run to your finish line or you walk to your finish line, however you want to do it. And the person hits the timer, it times you, tells you how long it took you to go that 20-foot distance. Again, you're free to walk or run, however you want to do it, as long as you get 3 different times. So here's my stopwatch. Gonna get started, see how fast I can do this. 2.41 seconds. 6.24, so you get the idea. Again, working on campus, you'll have 3 different people doing it at 3 different velocities. If you're by yourself, you got to get 3 different numbers. Now that we have our results or data, let's record them, graph them, and calculate our velocities. So, our distance was 20 feet, and our time, number 1, was 2.41 seconds. Our time, number 2, was 6.24 seconds. Now that we've got some data, let's put them on a graph and see what slopes we get. Now that we have our data recorded, let's graph them. Recall that velocity, a fancy word for speed, equals distance over time. This formula should be memorized. It is also written as V equals D over T for short. Notice that it looks like the definition or calculation of slope. That's because it is. Slope, M, equals rise over run. Therefore, when we put these data on the graph, we'll have distance be our y value. That's the vertical axis or rise. And we will have time be our x value. That's the horizontal distance or run. Let's graph our data. The first step in creating a graph, if our graph paper is unmarked, is of course to draw the x and y axes. The x being the horizontal axis, the y being the vertical axis. Normally we place those right in the center of the paper. Today, however, and I think for all of the projects we'll be doing this week, we'll be working entirely in the first quadrant. That's the positive part of the graph. So to give ourselves a little bit more space, let's put our x-axis down at the bottom of the paper and our y-axis over to the left, and label them just to help us remember. Now if you wish, you can number your axes, but you do not have to. So let's look back at our data. See what we're working with. So we've got our time and our distance. We know that our distance is going to be the y value, and we see that it's 20 feet. We see that our time is 2 seconds and then 6 seconds. So distance is going to be going on the y-axis because it's the top value, rise. Time is going to be going on the x-axis because it's the bottom value, run. Time 1 is 2.41 seconds, while our distance is 20 feet. So we're going to mark 2.4, 1, 2, and that's about 0.4 on the x-axis. And then we're going to go up 20. 1, 2, 3, 4, 5. 20. Here's our data point. That is for trial number 1. Checking our data again, our second time was 6.24 seconds. Our distance was the same, 20 feet. So 1, 2, 3, 4, 5, 6, and roughly a quarter, 0.24 right here. Then we're going to go back up 20. Put that data point right here. It's number 2. I might be better off to make it a different color. Alright, now we have 2 data points which we can use to define lines that will tell us in a visual way our velocity or slope. So let's do trial number 1 first. Our line will pass through the origin and our first data point. And then our second trial. Our line will pass through the origin, that's the 0, 0 point, and our second data point. Now we have a visual image of our velocities or rates of speed. We can see how the slope of the line from trial 1 is steeper than the slope of the line from trial 2. That means we were going faster in trial 1 than we were in trial 2. So the slope, the higher slope of trial 1 tells us that our first run was faster. The graph can also enable us to project or to make projections from these data to other hypothetical scenarios. So in the second trial, when I was walking, I went 20 feet, that's the distance, that's on the y-axis, but I traveled for roughly 6.24 seconds. Looking at the graph, I can answer the question, how far would I have gone if I had traveled for 4 seconds? 1, 2, 3, 4, 4 seconds. If I had traveled for 4 seconds, if we just draw a line straight up to where it bumps into our graph, we can see it bumps into our graph here. If I had traveled for just 4 seconds, then I would have gone the distance represented here on the y-axis. I would have gone 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 feet. So if I had traveled for 4 seconds, I would have gone 13 feet. That's another data point that we would have gotten in our second trial. So the graph can help us to project from one set of data to other sets of data. I could also predict how long, how many seconds it might have taken me to run further. If we extend the graph, or to walk further rather, if we extend the graph beyond our data point, we can project or estimate how long it would have taken me to walk, let's say 21, 2, 3, 4, 5, 6, 7, 8, 28 feet. So if I mark 28 on my y-axis, that's my distance, I draw a line horizontally to where it bumps into my blue graph. Then I can project how long it would have taken me to walk 28 feet if I bring that line all the way down to the x-axis and see where I end up. It would have taken me about 6, 7, 8, 9 seconds. So it probably would have taken me 9 seconds to walk 28 feet. So graphing data can enable us to make projections. So this is your project for today. You will need to get 3 different times over the 20-foot distance. Working in a team, you can do it with 3 different people. Try to make the times as different as possible. One person could walk, one person could run or jog, the other person could sprint. Again, if you're working remotely, you're going to do 3 different times just by yourself: walk, jog, and sprint. And then graph those data points and draw the lines with the slopes that represent velocity.